All right, hello, chemistry class. Today we are going to be talking about dimensional analysis. So, again, this is going to be our new unit. So, you will be watching this, taking notes today, and this will help you finish the worksheet that was handed out to you. Okay, so when we talk about dimensional analysis, what exactly is it? Well, dimension means unit, and analysis means problem solving. So essentially, you are solving or problem solving with units. So math using units to find the solution to a problem. And so with this day today, with day one, it's going to be very straightforward. Again, it's going to be a lot of unit conversion. But keep in mind that it may seem easy now, but use the steps that we take for this day and use it for the multiple days because it will get more complex. I can guarantee you that. All right. So we look at three different numbers. Right now, if you were to look at this, which number is bigger? Well, technically, yeah, 120 is larger than 5 than 21, right? But if we add units, we have to look at 120 pennies. That's worth $1.20. 5 quarters would be $1.25, and then 21 nickels, that would be $1.05. So again, the answer would be 5 based on units. That's why units are key. That's why units are important, because it tells us what the numbers mean. If we didn't have any units, then we would have no idea what we're talking about. If we look at the different conversion units, so again, we can write these in two different fractions. If we look at 1 foot, we know that 1 foot is equivalent to 12 inches. So 1 foot over 12 inches, that is equal to 1. All right. We do the same thing, 12 inches divided by 1 foot. Again, it's still equal to 1. So either way, this here is the same as this because it comes out to 1. But 1 foot, again, is equal to 12 inches. Now we look at density. The density of aluminum is 2.70 grams per milliliter. Well, what does this mean? Well, this means that 2.70 grams is equal to 1 milliliter. Okay, so what we see here is that we have 3 significant figures here, and then we have 1 significant figure here for the milliliters. So 3 significant figures for the grams, 1 significant figure for the milliliter. And so our rule of thumb for conversion factors that have decimal values, they are not unlimited, and you need to look at the number of sig figs. So again, if we're looking here, 2.70 grams is equal to 1 milliliter. There'd be 3 sig figs because of the 3 here. And so 1 gallon is equal to 3.79 liters. Again, 3 sig figs compared to the 1. 2.54 centimeters is equal to 1 inch. This would have 3 sig figs. 1 meter is equal to 39.37 inches. Again, 4 sig figs. And then 1 foot is equal to 12 inches. Because there is no decimal point here, this could go on forever and ever and ever. So there'd be unlimited significant figures that are seen here. All right, so why do we care about this? Well, this is going to help us with dimensional analysis and eventually stoichiometry. Okay, so for any type of word problem, we need to set it up. All right, so we first had to write down the given. Then we set up our workspace, and then we write down units of answer. All right, so example 1. How many dimes are in 30 cents? So, step 1, write down the given. We have 30 cents. Okay. Step 2, work up or set up the workspace. So, we have 30 cents. We're going to do our division part here, our fraction part here. And then we know that our unit is going to be in dimes. All right. So, this is our end goal. This is our start goal. And we have to fill in this middle part here to figure out how many dimes we have here. Okay, so That is our setup. The next part is the solution. Okay, so number 4, do I want to keep it? If you don't, write the unit on the bottom of the next line. Okay, so we do not, in this case, want to keep it. What can I change it into? Write that unit on top and then include the numbers, and then repeat until the answer to number 4 is yes. All right, so we start with 30 cents. We want to get the dimes. Do we want to keep this? Of course we don't. We want to get the dimes. So what I do know is that we have cents can be at the bottom here, like it says in rule number 5. And I know we could put dime at the top because we can convert cents to dimes. So for 1 dime, which is the dime that I want to get to, that unit, I want to get to dime, and I know that there's 10 cents in 1 dime. So 1 dime is equal to 10 cents, and I know that the cents from here is located at the bottom here. Step 6 tells us that cents cancel, and we are left with dimes. So yes, we are good here. We are at dimes, and now we could go to step 7. Okay, so cents cancel out. We're left with dimes here. Now our next step would be to calculate. Okay, so everything on top is multiplied, and everything on the bottom is divided. We plug the numbers in the calculator and do all the work. So we have 30 times 1 divided by 10. Why do we have that? Again, 31. So we multiply this. Once we multiply all this together, then we divide by 10. So we would have 3 dimes. So why only 1 sig fig, you ask? It's because of our 1 sig fig here, our 1 sig fig here, and our 1 sig fig here. And it is our technically least accurate example here. Okay. All right, more info on step 4. So do I want to keep it? Again, the it refers only to the unit. Don't recopy the number. All right. So you don't want to recopy the number. You just want to change the unit. The units are part of the calculation. So to cancel a unit, it must appear on the top and bottom of a divisor. So again, if we look at our example from before, we have the top and bottom of the divisor, and we will cross off the units, okay? More information on step 5. What can I change it into? This really means, what do I know it's equal to? Okay, so in this example, we wrote dimes on top because we know that 10 cents is equal to 1 dime. We also know that 100 cents is equal to $1. But while we could write dollar on top, it wouldn't help us solve the problem. Again, it would take more steps to get to the same answer. Okay, so again, what do we know is essentially, what do I know it equals to? All right, so metric prefixes. Again, we were looking at more, we weren't looking at the SI unit of things. And so with SI, what's really nice is that we can use prefixes. We can use kilo, hecto, deca, deci, centi, and milli. And each symbol or each prefix has a meaning. Kilo, 1 kilometer is equal to 1,000 meters. Hecto, 1 hectometer is equal to 100 meters. 1 decameter is equal to 10 meters. 10 decimeters is equal to 1 meter. 100 centimeters is equal to 1 meter. And 1,000 millimeters is equal to 1 meter. All right, so if we're to do certain conversions, we have our base unit. Okay, so if you go higher or lower, you're either multiplying or dividing by 10, 100, or 1,000. Okay, so for example, how many centigrams are in 5 grams? So I know that centi is here. I'm going to start with 5 grams. That's what I know. That's what a given. And my end goal is going to be centigrams. So I need to get to centigrams. I know I have to put grams on the bottom. And I know that centigrams is going to be on the top because I know that the grams can be converted into centigrams. So if I look at my chart, I know that I have to jump and divided by 10 here, and divided by 10 here. So 10 times 10 is 100. So there are 100 centigrams in 1 gram. So I would have 100 centigrams in 1 gram here. After that, I know that the grams are going to cancel out here and here. And now that I'm at my final unit, I can do multiplication up top here and multiplication down here, and then divide this by this number. So 5 times 100 is 500 divided by 1, 500 centigrams. All right, another example. Example 3. How many kilometers are in 12 meters? So again, I start with 12 meters. That's what I know. My final goal is going to be kilometers. And I know I have to, again, 1, 2, 3. So most likely multiply by 1,000. 10 times 10 times 10. So I have meters at the bottom. I know that my final unit's going to be kilometers or kilometers. So I know that there are 1,000 meters in a kilometer. So times 10 times 10 times 10. So 10 times 10 is 100 times 10 is 1,000. There are 1,000 meters in 1 kilometer. So I multiply my top here. I multiply my bottom part here. So I have 12 at top. My bottom is 1,000. So after that, let's see if I can fix this. I have 12. Why isn't it working? I have 12 times 1. That's equal to 12. I just have 1,000 here, so I'm going to divide that by 1,000. Sorry for the horrible drawing. Then if I were to use the calculator, I could cross this off with the meters, and then last but not least, 12 divided by 1,000 would be 0.012. So again, my final unit is kilometers. All right. Let's erase all this. So, class example. We are converting 0.015 meters to millimeters. All right, let me fix this. It's all right. All right, we're going to keep going. So I have example 4, 0.015 meters to millimeters. So again, here I'm looking at 0.015 meters is my start. 15 or meters would be my end goal. So I know that in 1 meter, there's 1,000 millimeters. So I can cancel out my meters here. So 0.015 times 1,000 would be 15 divided by 1. We have 15 here. 0.35 hours equal to minutes. So I start